There we go. Part B of 17. So 17 says, as a researcher for a pharmaceutical company, you are designing a study to test the effectiveness of a new treatment for migraine headaches. You've been given a list of 126 people willing to participate in the trial. The first 70 people are female, the remaining 56 are male. The subjects will be randomly assigned to the new medication or their old/current medication. So nobody's going to be taken off of their medication. The control group will be the group that is just staying on their regular medication here. Part B, preliminary research suggests that men and women respond differently to this new treatment. What sort of experimental design would you choose for this study and why? I would go with a block design. Randomized block design is going to help control for the potentially confounding variable of gender. Oh, let me go back. So blocking by gender will help to control for this confounding variable. Ran out of room. Oh, sorry, guys. Why would we care about controlling for a confounding variable? It's going to skew the data. So we would say that this will reduce variability in the response variable. Not necessarily when we know, but when we suspect. When we suspect that these particular characteristics have some influence that could end up confusing our results. So it's not just going to reduce the overall variability in the response variable. It's going to allow us to see the differences between the responses of men and women. Mm-hmm.
What did you say was the difference between blocking and straddling?
Give me half a second or I'll start writing my answer to you and not the words that I'm trying to write here. Okay, so the difference between a block design, specifically we should say randomized block design, difference between block design and stratified random sampling, because it feels very similar. Stratified random sampling is how you pick out the people that are going to be involved. In this case, there are 126 people who have said they are willing to participate. We have no idea how these people were actually selected. Probably not randomly. These are probably volunteers so that there could be completely informed consent. You can't just go switching medications on somebody that doesn't know and is not okay with it. That would be unethical. So how you pick out the people that are involved, that is a sampling method. So stratified random sampling would be to say, if we had everybody that is taking medication for migraine headaches, and I randomly selected 70 women and then randomly selected 56 men from that population. That would be stratified random sampling. Block design for the experiments has to do with how I'm deciding what to do with the people that I already have. So once I have these people, if I think there's some characteristic that I would have liked to stratify for, but I'm working with a group of volunteers here, now I'm going to take what I would have used for my stratified selection, and I'm going to divide them evenly into, in this case, 2 groups because we have 2 treatments, old medication, new medication, and I'm going to randomly assign each of my blocks, which are similar to strata, but again, strata is how you pick out the people that are going to be involved. Block design is what you do with them once you have them.
So could you have both stratified and block sampling together? Like the people were selected stratified, but then for the actual experiment we did the block design?
You could, yeah. That would be a very complicated design, but yes, it is possible. So you could, randomly select things, say, especially if we were doing some kind of sampling at the grocery store, randomly select stratified, and then go do an experiment and keep them divided, block using the same things that we use to stratify. Yes. All right. What else would you guys like to talk about here? While you're looking, I have a question for you. So we have completely randomized experimental design. That's where you just take everybody that's involved and you randomly assign them to which group they're going to go. There's the randomized block design. What was the other one that we talked about? Matched pairs. Matched pairs design. So you're going to put the 2 most alike things together. That will be one of your matched pairs, and one of them gets assigned to one treatment condition, the other one gets assigned to the other treatment condition. Then you do the same thing with the 2 most similar experimental units. There we go. I lost my vocab word for a minute.
So for the random sampling I did on FRAPPY, I labeled them like the girls and boys, like month or whatever, and then I said even numbers, establish curve medication, and odd numbers keep their own traveling medication. Is that a good way to do it? Does that make sense?
So you assigned numbers to everybody.
I did the girls 1 through 70, and then the boys 1 through 56, and in each individual one, odd numbers got this and even numbers got that.
So there's a way to take that and make it a good way to divide it, but the problem with the way you have it set up right now is there's nothing random about it. You assigned these people's numbers. That was not random. And then you decided even numbers get this, odd numbers get this. If you had flipped a coin, heads, even gets the new treatment, tails means evens get their old medication, and then the odds would get whatever the evens didn't get. Now you've introduced that random component that's really important in our experiments. So if you included that piece, then that would be great. Yes, Sarah? Number 16? Absolutely. Whole thing? Yep, not a problem. Vitamin E may have special health benefits. Large doses of vitamin E apparently can reduce harmful side effects of bypass surgery in heart patients. A study involving 28 bypass patients found that 14 randomly assigned patients who took vitamin E for 2 weeks before their operations had significantly better heart function after the procedure than the 14 randomly assigned patients who took placebos. The vitamins apparently prevented damage to the heart muscle by destroying the toxic chemicals called free radicals that form when blood is cut off during the surgery, said Dr. Terence Yao of the University of Toronto. Explain why this is an experiment and not an observational study. So I would start my answer full sentences here. This is an experiment because a lot of times I'm going to just reuse their wording for my STEM. right, so this is an experiment because why do we think this is an experiment? What does an experiment have to have? Treatment. Yep, because treatments and now instead of writing a whole nother sentence, I'm going to stick those in here. Vitamin E versus no vitamin E. Yep. I haven't seen scoring guidelines that are consistent on that. I would always err on the side of, if I'm talking about treatments, I want to name what they are. Almost all the questions that I've seen on the AP exam do ask you what the treatments are. If that's part of the question, if they ask you what the treatments are already, then you wouldn't have to include it in your sentence because you already showed that you know that information somewhere else in the question. But if they don't ask it somewhere else in the question, I would probably put it in there because that's probably a piece of what they're looking for there. So this is an experiment because treatments, vitamin E versus no vitamin E, were decided on by who? The random assignment. So these are imposed or randomly assigned on the subjects, patients, experimental units, however you want to word that here. The patients in this particular study were not given the option, they were not given choice. They were randomly selected to be part of one group or another. And because that treatment was imposed on them, they were randomly assigned to one of these groups. That's what makes it an experiment. Identify the explanatory and the response level, or variables, sorry. What's our explanatory variable? Yep. Whether the patient took vitamin E or not. And we just saw on that one AP exam question, including that or not, is your saving piece on this. You have to talk about, like, this isn't one where you could kind of take vitamin E. You either take it or you don't. So there's only two possible categories here. If there are three possible categories, you want to include all three of those. 4 categories, include all 4. So what would our response variable be then? Heart function after surgery. Specifically what? Because remember, we talked about this has to be measurable. Is the first variable, explanatory variable, is that measurable? Can you see or observe? Would someone have access to that information that you have a yes or no on that? Yes. So if we say heart function after surgery, like, what do you mean? Destruction of free radicals. Do we have tests for some of these things? Yeah, we can test someone's level of heart function. So I would say the level, because that's measurable, just heart function, like, I got to talk about how we are getting this output. Like, what's it look like? Level of heart function. I don't know what the actual test is, but I know that tests exist that can look at your heart is functioning at 50%, your heart is functioning at 75%, your heart is functioning at 100%. So we have those different levels that we could measure, and then we could use that information to compare between the groups. Identify the type of experimental design used in this study. Justify your answer. So I did just ask you a moment ago to talk to me about the 3 different experimental designs we have. There's completely randomized, there's randomized block design, And there's matched pairs. From the information that they gave us, it appears that they used which design? Completely randomized. They didn't talk about any blocks that they identified before, and they weren't matching their patients that had the best heart function and then the second best heart function and third best heart function. They took all of the people that said that they were willing to participate, and they randomly assigned them to these two groups. Each subject or patient is randomly assigned to one of the two treatment groups. Yes?
So you don't have to mention the placebo that they put in there.
Not when I'm talking about just what design was used. If I was asked to talk about that design or to design a study using a randomized, completely randomized experimental design, then I would have to talk about, like, I have my one group that is getting the vitamin E, and then I have my control group that's going to receive the placebo, which both of those things would be considered treatments. Part D. In the second sentence above, the phrase, the 14 patients who took vitamin E for 2 weeks before their operations had significantly better heart function after the procedure. Can the results of this study be generalized to a larger population? What do we have to have in order to generalize to the larger population? Random selection. Did we have a random selection of the participants in this study? No. No random selection. This has to do with how we pick out the people that are involved. So no random selection. So no. We cannot generalize to the larger population. We can only generalize to the participants in this study. Or we can only talk about the patients in this study. Why do you think they didn't use a random sample? Be unethical. If you want to generalize to, like, just the population of the United States, you would have to have a random sample of people from the United States. Then you'd have to randomly assign them to one of these two groups, have them take the medication or the placebo for 2 weeks, or sorry, vitamin or placebo, and then you would have to do heart surgery on them, whether they needed that heart surgery or not. So that would be completely unethical to do. Yes?
How does random selection fall into random sample, random assign? Because it's not on the chart.
Got it. So random selection would be random sample.
So it is still
Yeah, if I say they were randomly selected, that's how we picked out the sample. That's how we chose who was involved in the study. Yes.
Okay, so random sample is anyone from anywhere have the opportunity, and random selection is their
So random sample, random selection. I'm using those in this particular sentence interchangeably.
But
Yes.
in general.
In general, like if I said there was no random selection, I would read that sentence the same as there's no random sample. If you were to talk about the Taylor Swift sampling that we did, we could say that we, if you turn around and look at the green one, it's all the way in the back of the room. The green one, when we did a simple random sample, we randomly selected, using a random number generator, the people for that sample. So selection is more like our verb, sample would be the noun, but it's pertaining to the same thing. Does that make sense?
Yes.
Okay. What about cause and effect? Can we infer cause and effect? Yes. Yes. Because why? Yes. So I got to include more in my sentence, not just yes. Yes, we can infer cause and effect because the subjects were randomly assigned to the two treatment groups. All right, and then this one has a part E. What if the results of the study are not statistically significant? What would that mean in context? They love asking these in context. So you have to talk to me about patience and heart function, or patience and free radicals, or what have you. So if I told you that the results of this particular study were not statistically significant, how would you take that and turn it into something that would make sense to your parents?
I'd say you can't exactly declare that vitamin E reduces the harmful side effects of vitamin C.
So what was probably responsible for the results seen in this study if we determine it's not statistically significant? Louder. By chance. The results seen in this study were most likely due to chance and not actually due to the vitamin E. Good grief, my handwriting's really bad right now, sorry. Is it possible that we determine the results of this study are not statistically significant, so we say it was most likely due to chance? Is it possible that we're wrong and that the vitamin E really did make a difference? Yeah. It's most likely due to chance. That's what's not statistically significant would imply to us. There's always the chance that we made a wrong call, or that we just got unlucky in the selection of people and there were other confounding variables that we didn't know about that we couldn't control for. This is why you'll see the same experiment performed different times in different places with different samples. Because the more you can, especially because we can't generalize to the whole population, if you show over and over and over, well, with this group of people there was cause and effect, and this group of people there was cause and effect, and then over here too, then we're going to end up with this like amalgam of evidence that says, okay, we can probably say that this is cause and effect for the general population at large. We have about 9 minutes left. What do you guys want to do? Which ones do you want to go over, or do you want to do some multiple choice practice?
We want to study or study guide. Can you do like number 8 and 9?
8 and 9, absolutely.
Is the field
Is the review on Canvas?
the
Answer key. You have to actually get into the module, but yes. So if you go like to today's module and you scroll all the way to the bottom of that page, the answer key is there. Yep. Number 8, control groups are used in experiments in order to accomplish which one of the following? Limit the effects of variables other than the explanatory variable on the outcomes. Control the subjects of a study to ensure that all participate equally. Guarantee that someone other than the investigators who have a vested interest in the outcome controls how the experiment is conducted. Achieve a proper and uniform level of randomization, or reduce variability in results. The correct answer here is A. Control groups are used to limit the effects of variables other than the explanatory variable on the outcome, on the response variable. What we're looking for here and why we have our control group, if you don't have a control group, you don't have any basis for comparison here. Maybe it's due to the thing that you're testing, but if you're only testing different levels and you don't have that control group there that doesn't get the active ingredient, then it's possible that it could be due to some other variable that you haven't taken into consideration. Number 9, a survey is to be administered to recent graduates of a certain nursing school in order to compare the starting salaries of men and women. For a random sample of graduates, 3 variables are recorded: sex, starting salary, and area of specialization. Which of the following best describes a conclusion that can be drawn from this study? When I see this right here, I'm asking myself 2 questions. Was there a random sample? Was there a random assignment? When I'm asked about conclusions that I can draw, those are the 2 things I'm going to ask myself. Because doing a study on people, if I can't take that information and say anything of value to anybody else, nobody's going to fund my next project. They want me to come away to say something of value to people other than just those that were involved in the study. All right, so do we have a random sample here? Yes, random sample right there. Do we have random assignment? No. Yes, Eni. Oh, sorry, I thought you were raising your hand there. So random assignment, or random sample, yes, random assignment, no. What are we allowed to say with random samples? We can generalize to the population. What can we not say because we don't have random assignment? Cause and effect. Part A, whether being female causes. Already, I'm done. Whether being female causes. I don't even need to see the rest of the sentence. I'm done. Whether choosing a certain area of specialization causes. Done. Whether there's an association between sex and starting salary among graduates of this nursing school. Whether there's an association between sex and starting salary at all nursing schools. So what was the, now they're getting at like, what was the population? It says we can generalize to the population, but what was our population? Where did our sample come from? Yeah, a certain nursing school. It was not drawn from a random sample of all nursing schools. They're only picking them out from one nursing school, so we're only going to be able to generalize to graduates at that nursing school. If you do not have random assignment and you see the word causes anywhere, throw it out. You're done. You don't even need to read the rest of it. Do you have any other general questions for me? We got like 4 minutes till the bell. You guys should have the Chapter 4 important information that was that PowerPoint that I printed out for you. You should have that flashcard packet on the purple paper that you picked up on your way in. Those two are fantastic resources, along with looking at the questions on your study guide. What are the big ideas that we're hitting on here? One thing that I can tell you I'm definitely going to be looking for is, can you identify or describe sampling methods? Like if I described something, could you tell me whether it was cluster or stratified or simple random sample, or I'm leaving one out. Hold on. Stratified, cluster, systematic. I knew I was leaving one out. Does anybody remember systematic random sampling? Yep. Yeah, you pick by a pattern. So you choose a random starting place, but then you use a pattern, some kind of system every 10th, every 15th, every 101st, whatever. I'm also definitely going to ask about experiments. I don't know if you guys noticed, but the 2 FRQs that I picked out, and I know last year and the year before, they asked about what are the treatments, what's the explanatory variable, what's the response variable, design an experiment. Something that you have to have, whether we're talking about sampling or experiments, is what starts with an R. Randomization. There has to be, like, if I'm doing a simple random sample, I have to talk about how I mixed things up to randomize it, or I have to talk about how I used a random number generator. If I'm designing an experiment, I have to explain how I am randomly assigning these people. You have to talk about what happens if, like if you're talking about a coin flip, what happens if it lands on heads? Also, what happens if it doesn't land on heads? Talk about both cases. Talk about what happens to your other group as well. If you don't talk about it, they assume the other people are just sitting over there kicking dirt. You don't have them actually doing anything because you didn't say it. I will be available today on Canvas. If you need me, send me messages on Canvas. I'm more than happy to. I'll be staying for about a half an hour after school today. I have told all of my geometries that I am not staying after school today because this is only for statistics people if you want it. So till 3 o'clock, I have to be walking out the door at 3:15. So about a half an hour today if you want to come in and get a little bit of extra help before this test.